Berkeley, is that correct?
No, Carnegie Mellon for my PhD.
Carnegie Mellon for his PhD, but you taught at Berkeley? Where did you teach?
Rutgers. Oh, no, I know what you mean. I was at Stanford for years, a research associate.
Stanford, okay.
And then I was research scientist or something or other at USC Information Sciences Institute.
I knew I'd read
University of
that.
Southern
All
California.
right. And what? Has nothing to do with Berkeley, you're right. But he is going to share with you what he has developed in the way of an interactive reading tutor. And it's a project that he has worked many years on. It's also been patented, and it won one of the most, Nifty 50 awards?
That was NSF in the year 2000 something or other. Chose 50 projects that it thought even Congress could understand.
and this was one. So I'm going to turn it over to Jack, and hopefully in a moment you'll get everything going.
Yeah, let's see. Okay, doesn't. So I'll just have to do that. Okay. So I kind of feel like, how many of you have seen the movie The Wizard of Oz? Okay. Remember the scene about paying no attention to the man behind the curtains, because that's kind of what I felt. All right, I'm going to get comfortable here.
Good luck.
Thank you.
Yeah, that's really
Those
reassuring when the technology people
Yes.
leave and say
Those
good
are
luck.
exactly. Amazing, I'm sure. Those are exactly the two words one most wants to hear. All right. The only, actually, if I could get some water, that would be great.
All right.
So, my title today is What Can We Learn from Reading Tutor Lessons? And I have way more slides than I can show within the amount of time that a posterior can tolerate. So I want to get some audience input as to, there's particular places I'll say, give you choice. What I will tell you is that near the end, there's a rather long segment with a bunch of video clips of vocabulary instruction. And it takes time to go through all the steps of the experiment there. So the more time I spend on things up front, the less time I'll have to prepare. Okay. Oh, so first of all, I want to thank my funding sources, past and present, and the army of people of whom this is just the some of the more recent ones who have contributed to the work you've seen here. So that's faculty, graduate students, and very dedicated staff. This is Herb Simon. How many of you have heard that name? Father of artificial intelligence, at least as much as anybody else. Nobel laureate in economics, and I think it was 1979. It was like Nobel caliber at half a dozen different fields. A true Renaissance man. And he used to give a talk on how to do research. How many of you are undergraduates? How many of you are graduate students? Okay, this is for you two. And for the rest of you, if you ever become graduate students, and how many of you might want to do research someday? Perhaps that's the question I should ask. Okay, I'll skip to the next slide then. All right. So when I speak to a non-education audience, I have to explain what I mean by reading. So please don't be insulted by this slide. All right. The point is reading is multiple skills. So one of them, often does by phonics, is taking a printed word and mapping it onto some full representation. Sorry about that, somebody's audio is a little loud. And then this is the part of the muscle movements that produce speech. And the mapping the opposite direction we call spelling. It occurs to me that mapping might be geek speak. I don't know if you have another term to mean going from here to there. But that's what when I say mapping one thing to another, that's what I mean. Fluency is the ability to do that quickly, accurately, effortlessly.
My cat is fat.
And expressively. Vocabulary is retrieving from some mental representation, or from the sound of the print, some representation of the meaning of the word, at least as I use it. And comprehension. Okay, sorry to those of you who just woke up. Welcome. As a very eloquent principle of the first school where we have Reading Tutor Park for some amount of time, it's called to make meaning from print. That's the ultimate purpose of reading. But it takes all of these skills and then some to be able to do it. Now I'm going to switch to a, let's see. I'm going to have to play the video separately. Here we go.
First, click on your name.
At Fort Pitt Elementary School, a second grader named Aziza gets reading help from a dedicated mentor.
Choose a story to read.
Oh,
Old Mother Hubbard.
Software called the Reading Tutor listens to Aziza and offers help.
Please read aloud.
Old Mother Hubbard.
The Reading Tutor is part of a new wave of computer software now being used to supplement classroom instruction. The system's designer is Dr. Jack Mostow.
It is very easy to explain in 4 words. Children read, computer listens. What the Reading Tutor provides is lots of infinitely patient assisted practice in oral reading. And that's a missing ingredient for all too many children whose parents or teachers don't have time or in some cases ability to listen to them read aloud.
Went to the...
When Aziza gets stuck, the Reading Tutor can sound out a tricky word.
Cupboard.
cupboard.
You're a great reader.
To keep young readers interested, the computer can offer a variety of clues.
Rhymes with phone.
Bow.
Getting a computer to understand spoken words is a big challenge. The Reading Tutor software must cope, just like our ears and brain, with the fact that the same word can be pronounced in different ways.
Old Mother Hubbard
went to the cupboard.
cupboard to get her poor dog
a bone.
bone.
But when she got there, the cupboard was bare. And so the poor dog had none.
Isolating the sounds of speech is difficult even for high-powered computers. No wonder children sometimes struggle as they try to develop phonemic awareness.
Let's read this sentence together.
But with help from the Reading Tutor, Aziza is making good progress.
To get a poor dog.
Aziza came to me at the beginning of the year, pretty much a non-reader. She had a very limited sight vocabulary. She was very insecure about her reading, very reluctant reader. She's ready to take a challenge now. She'll try anything. She loves to read.
A bow.
Very good.
One of the first to test Mostow's technology, Miss Prevost wasn't thrilled about the idea at first, but she's become a supporter.
It's a part of the classroom environment. The kids move back and forth from it without it interrupting any of our routines. It's become a friend more than a threat, which it was at the very beginning when I first started to use it.
The system is now running in 20 classrooms around Pittsburgh, and Mostow's studies indicate it's working.
When I explained these results to the principal in my long-winded academic way, she boiled it down beautifully. The children who used the Reading Tutor were closing the gap.
And so the poor dog had none.
You're a fantastic reader.
I don't know if any of you have heard of the Reading Rockets series. I'll put this back up. Produced through the Department of Education, but that's a 3-minute clip from, I think, the 3rd episode. Now, let's see. Right. So that's the reference. By the way, that video is on our website, and so are our papers and some other videos. What can we learn from Reading Tutor that listens is the title of my talk today. The first thing I want to convey is 3 things about the Reading Tutor. It's a delivery vehicle for instruction, so it provides individually assisted one-on-one practice in oral reading, machine-guided oral reading. It's a research platform that's exquisitely instrumented because it logs all of its interactions with kids second by second, millisecond by millisecond over the course of the entire school year with all kids. And third of all, besides sort of observing, logging what it's doing with kids, it can actually not just be passively observing things, but actively doing experiments, in particular randomized controlled trials, which we love to do. You'll see, you just saw some of the first aspect of this in the video. It's an old video, but it still gets the basic idea. Child reads, computer listens. And what I want to do in the rest of the talk is first show you what we can get just from analyzing that data. How many of you have heard the term educational data mining? Okay. Hopefully you'll find that interesting. And then some of the experiments that we've embedded in the Reading Tutor and their results. So over this 20 years, what have we learned about reading itself? Because I figured you might find that interesting. All right, so there's a bunch of different sorts of research questions that we look at. An obvious one, so I just want to get it out of the way, is, well, does it help overall? And in order to do that, we do studies that compare pre to post-test gains, and we compare it against some alternative. We've done some of these studies, and some of the control conditions we've compared to a sustained silent reading. How many of you have heard of that? All right. D or drop everything, and we use another name for the same thing, independent reading practice. I like that as a control condition because it's widespread and it's reasonably well defined. Whereas business as usual varies from school to school and classroom to classroom and possibly day to day. ELBO here, ELL is English language learners. And this was somebody's master's thesis at DePaul University. And these were all independent studies. We provided a bit of assistance. But at the Reading Tutor in Canada, in Ghana, Africa, which where the title slide was taken, that was the Kofi Annan Technology Center, in Bangalore, India. I've never set foot in Africa or India, so that's, I get a kick out of that. All right. When we first started, we thought, well, suppose you had a magic box that could listen to a kid read. What should it do? And a Wizard of Oz study is something you do where an experimenter controls what's going on the screen. And so the experimenter can very quickly change what they do. And that way you can design the interface, the look and feel, before you do all the work of actually implementing your code, which takes a lot of time and is hard to change. There's some stuff about speech recognition. This talk is going to focus on what kinds of practice and assistance help. And those two things, by model it, I mean take that data that you just observed and try to extract some meaning from it. RCTs are randomized controlled trials. Sorry for the TLAs, three-letter acronyms. My wife worked at IBM and now works at Oracle, and so I'm used to hearing lots of TLAs. And then there are other sorts of questions like whether kids like something, whether it actually helps them. Assessment is a whole area. Prosody data is another kind of thing we did. So this is just simply where I ran out of room on the slide. This is what I'll focus on. All right. So here's a learning curve. Have you seen learning curves before? Okay. They won't bite. This learning curve came from averaging 750,000 words read aloud by kids at the Reading Tutor. And how many of you have taken psychology courses? Okay. Do they make you like run subjects for experiments? And do you use a clipboard for that to keep track of subjects? Because that's sort of this mental image of the poor psych researchers is, and I see a knowing nod, running the requisite 30 subjects or whatever. So I love to say no clipboards were harmed in making this data. So what this is a graph of is for less frequent words. So this isn't like the Dolch list for those of you who know what that is, or the real high frequency words. On average, all across all the kids and all the words, how long did it take them the first time they read it, including the hesitation beforehand? So that was 1.6 seconds or so. And then by the fourth exposure, it was down to 1.3 seconds. And you can see there's this long tail where it slowly declines. The dots are the actual averages. and that curve is just a fit of what an exponential model would look like. So an exponential model, there'll be a little bit of math, and I think this is practically all of it, in fact. And I know at least one of you likes math, yes. Sorry, I didn't mean to out you in front of everybody.
That's fine.
Okay. Good.
Good.
Yes. Math. All right, so here's that sort of an idealized form of the graph that you just saw. So this is an actual exponential scale model, which is why the dots all land neatly right on the curve. And better here is a very abstract word I've chosen on purpose because it can mean different things. Learning curves, this could mean faster, so this could be time. It could be percent, the error rate. It could be how often kids ask for help, like how many words they click on for help, that percentage. And then number of tries of skill is just how many times have they practiced this particular word. Okay. Let me unpack the math. A is just the performance on the first encounter. So the graph on the previous slide would be how long did they take the first time they see it, which would average 1.6 seconds. E is a mathematical constant. Dot is how mathematicians write multiplication. I don't want to take anything for granted. So please don't be offended. Okay. B is the slope of this curve at the starting point. So that's the learning rate. How fast or slowly does this student learn? And T is this thing that psychologists like to call trials. I don't know why. Maybe could just believe they're not lawyers. Who knows? So this form of curve, that, or also something called the power law of practice, used in lots and lots of psychology models. Now, I had a colleague, Joe Beck, who had a flash of wonderful insight. Very simple, very powerful idea. And since in the long run we're all judged by the quality of our PowerPoint animations, it's also conducive to a nice, I'm really proud of this sequence, as you will see. Okay. His idea is that not all practice opportunities, not all tries are created equal. Some kinds might be better than others. Okay? So suppose there's two kinds, type 1 and type 2. Then instead of just having the total number of trials, because this formula implicitly is saying one trial is good as another, performance just depends on the total number of trials you've had. Well, suppose you say, well, it's not T. There's T1 trials of type 1, T2 trials of type 2, and we're going to stick a coefficient in there, beta, and that says how much is a type 2, I'm using the words encounter, practice, opportunity, trial, also mean the same thing. How much is a type 2 practice opportunity worth compared to a type 1? So if beta is more than 1, it means type 2 is better. If beta is less than 1, it means type 2 is worth. If beta is 0, it means type 2 is worthless. If beta is 1, they're equally good. Now, here I just had two types of practice, but this idea generalizes, so you could have a bunch of different types of practice. This is a very simple, very powerful idea. You can go out, you can try this at home if you've got lots of data. And that's what we did. So what I'm going to now summarize, these are different papers that use that analysis method to mine this gold mine of data that we have from hundreds of kids reading, millions of words, to answer research questions in reading, some of which might actually be relevant to those of you who become teachers and teach kids reading. So we started with something that's well known in over a century of psychology research about spacing and practice. And we wanted to compare how effective is it to see a word twice on the same day compared to the same word on 2 different days. And it turns out that seeing a word again today, in terms of your future performance, is worth only half as much as the first time you saw it, according to the values of beta that we get from fitting that formula into lots of data. Now, here was a more open question. Is it better if you're a kid learning to read and trying to build your fluency to read the same story twice or 2 different stories, given a particular amount of time you can spend reading? So that's, the first is called repeated reading, and the second is called wide reading. It was an open question in the literature because it's hard to measure. According to our data, seeing a word on average overall for all the kids in our data, seeing a word in a context that you've seen it before is worth only about half as much as seeing it in a new context. So overall, that says wide reading, A3 reading, if you want to build fluency. I'll just say a little bit more about that result, because there are some exceptions to that. Down at the low end, some further very clever analysis by Joe suggested there are some kids who benefit from rereading more than wide reading, but they're like 5% at the low end. So the tutor takes turns with the kids picking what to read. Does it matter? Bill was asking me about tutor versus kid selected stuff. And according to the analysis that Joe did, yeah, it does. They learn about 25% more, and by learn here I'm talking about improvement in fluency at a word-by-word level. So improvement in word reading time. So the individual word is kind of the micro unit of fluency. How long does it take to read a word? And then I was interested, when you read a word, how much transfer is there to performance on another word? So if you read the word cats, how much does that help you with the word cat, or vice versa? With this sort of data, we could answer that question. And it turned out that seeing a word with the same root was about half as good as seeing the word itself. So there's like 50% transfer. That's pretty good. Seeing a word with the same rhyme, and R-I-M-E, that's not misspelled. It means if you chop off the onset, like the h, you take that away from the word what's left. So here it's at. So enough seeing a rhyming word. That was worth only about 1/8 as much. In fact, it was not statistically significantly different from 0. That surprised us because there's a big fuss about word families in elementary reading books, and they're supposed to be great. Maybe they are for decoding. That's not what we're looking at. We're looking at does it help with fluency, and it didn't seem to that we could measure. All right. Here's one of those choice points I mentioned. I think I'll tell you about this slide, and then I may skip a few, unless there's a lot of interest in seeing more about this stuff. So I showed you the learning curve, the exponential curve, as a way to model practice. Here's a different method. It's something called knowledge tracing that was published in 1995. And it's a very simple model of learning. What it says is that, so here's the thing with learning. You get to observe the student's performance. You cannot directly observe what they know, only what they do. You're not allowed to go in with a scalpel and see, even if you did, besides you'd be in a lot of trouble, you can see it. So the student knowledge is a hidden state that we're trying to infer. Knowledge tracing has a very simple model. For a given skill, like a particular word, at any given time step, the kid knows it or they don't. Okay, so and K sub I means that time step I, they know it or not. Now, they might have known it to begin with, and that's this parameter do. These 4 or 5 things here are probabilities. They're parameters of the model. And then at each step, just because they know it doesn't mean that they get it right. They might slip. So slip is just the probability, if they do know it, of screwing up. Careless errors. Conversely, just because they don't know it doesn't guarantee they will get it wrong. Especially suppose it's with something that's a 4-item multiple choice question, they got 25% odds of getting it right just from pure dumb luck. So that's guess, which is that probability. And then there are these learning probabilities. Learn at any step is the probability if you didn't know it, the light bulb going on and knowing the next step. And forget is the opposite. It's often assumed to be 0. And by fitting lots of observed performance data, you can estimate the values of these parameters. And then intelligent tutoring systems use these things to estimate the probability at any step that a student knows a skill. So an intelligent tutor that uses knowledge tracing if its estimate of the probability that you know a skill reaches 95%, we call that mastery. Or that's typically a mastery criterion. I think I might skip some stuff to get to the, this was really cool, but I'm gonna skip it. Trust me, it's really cool. Anybody asks, you can like put papers. I'll put papers on the website. So I wanted to, that's sort of abstract, it's really cool, but let's get back to more concrete things that we find more relevant. Okay. So what I showed you so far was the learning curves, which is a way to just analyze data to collect, and knowledge tracing, which is also a way to analyze data to collect, except I didn't say very much more about it. And now the rest of the talk, I'm going to show you various experiments the Reading Tutor has executed for us. And one of them, and this is not the simplest one that I'm starting with, but I wanted to have all the stuff about fluency and then get to vocabulary. The tutor, if the kid clicks on a word, you may have seen in the video the tutor giving a rhyming hint. So it has about 10 different types of hints it can give. So imagine the kid's reading a story. And I made up this example just so it would fit in this space there. So suppose the kid's reading, people sit down and the next word comes up, and it's R-E-A-D, and the kid, for this example, clicks on this word because they don't know what it says. By the way, it could be read, it could be read. You'd actually need to know the context on which it is. At this point, here's the random part. Tutor has about 10 different types of help it can give. Not all types apply to all words. So it can't syllabify a one-syllable word. It can't give a rhyming hint on the word orange. Anybody know why?
There's no word that rhymes with orange.
Exactly. So the kid typically will echo the word and be the rest of the sentence. Now we want to know not whether the help is helping immediately, but whether it's causing any learning. So what we're interested in is some time passes. The next time the kid encounters this word, do they read it fluently? That's the outcome that we're interested in. So we're going to define success as the tutor, which is just automatic speech recognition, which is far from perfect, accepts the word as read fluently. And read fluently means without hesitation. All right. The question is, we have these like 10 different types of help. I'll show you a couple examples. Does the type of help make a difference? Does it really matter what kind of hint you give a kid on a word? Or is it all pretty much the same? And if it does make a difference, which ones are better or worse? So, you know, I love to show these big numbers to psychologists because they don't get to see ends with these sorts of values. So we had 180,000 words read by 270 kids, and on average, 2/3 of them, the next time they ran into them, they read fluently. I just am going to illustrate a couple of them. So here's just saying, we'll see if this works.
Cat.
All right, someplace there's a video there, and I'm not going to bother doing it, but it just highlights the word and says it. So that's whole word help. With the word read, it would say read or read. Saying in context would mean it would just play back the part of the sentence recording that's narrated human speech. So that would tell whether it's read or read, depending on how it was narrated. Some types of help just focus on a single element. So they break down a word into syllables, or onset in line, or sounding out phoneme by phoneme, or just saying, for example, EA here makes a sound E. So just a single grapheme. Or I here makes a sound I. The letter I here makes a sound I. Analogy, example there would be rhymes with, and here I'm going to try to, let's see.
Cat.
All right, well that worked. And where is, I don't want to waste time. Rhymes with, it would say, under cat, it would show the word hat, and say rhymes with hat. And then it would say, what else rhymes with cat? So it would say rhymes with mat. But it wouldn't say what the word was, so it's up to the kid to figure out that it's a cat. And then there's some things that I call semantic, meaning they're meaning oriented. We have sound effects. We have, what you saw was not the meow was the sound effect for cat. We have some pictures. Re-cue would be like, people sit down and read a blank. So that's putting kids back into context to try to see whether they can guess it. So that's it. That's people sit down and read a, that's reasonable. People sit down and blank is not a very good hint. And actually, people who advocate, human tutors who advocate this sort of hint would only use it when it was predictable. The reading tutor didn't have that kind of smarts. Which type stood out? Rhymes with one overall, and re-cue sucked, to use the technical. And because we have so much data, you get tight confidence bands. So we can say pretty confidently that re-cue sucked. Also, it sucks internally. The kids can click on a word, and every time they click on a word, the tutor chooses randomly among the types of help that it could give. So even if it's already in the middle of giving help, 2/3 of the time they interrupted the re-cue. They really did not like it.
So the best is rhymes with. Is that what you're saying?
Yes, but now I'm going to say something slightly
May I ask you a
different.
question?
Yeah.
Doesn't that contradict what you said earlier about word families? Because word families basically have the same rhyme, different onset.
We wondered about that too. All I've got to answer that is speculation.
Speculate.
Sure. And the well, first let me get through this slide.
Okay.
Is that because what helped depends on how long before they saw the word again. So if they saw the word again the same day, just saying the word worked best. If they didn't see it until a later day, these are all rhyming hints or things like it. So the rhyming hint forces them to do some active processing, and that may be good for them. Whereas the transfer, I don't have a great explanation for it, except maybe the following. I don't have the slide to go with this. Our brains are very predictive. So one reason people sit down and read my work is that you can predict it's going to be a book. And even if you hear part of a word, like I went to the store and I bought a hat. Now, before I got around to the t, you knew it was going to be a t. You didn't even think about it because our brains are predictive. With the rhyming hints, with transfer, there's no time at which you've heard only the rhyme because you always hear the onset first. So anyhow, we can chat about that more. Okay. I don't pretend to have a definitive answer to that, but it does show that you were paying attention. All right. So the motto here seemed to be that just giving the word helped the best in the short term because of recency effects. Because if they're going to see the word again the same day, often that would be minutes later, the same story. But rhyming hints really seem to have some staying power. All right. Here's a more recent experiment that we presented at the Society for the Scientific Study of Reading in Montreal. Montreal was fun. And this is another experiment. And the question here was how much context is best for building fluency. So by how much context, you could practice isolated words, or you could practice words in running text, or you could practice words somewhere in between. Now, you might think that the best sort of practice would be practicing words in isolation, because if you practice them in isolation, you can say the word in isolation without the help of any context. Surely you should be able to say them in running text. Surprisingly, that's not what research had shown. There were discrepant results. Some said that reading in context was better. Some said that practicing isolated words was better, until Sandra Martin Chang looked carefully at the studies and noticed they were using different outcome measures. The ones that found that isolated word practice was better were the ones that were using isolated word reading as the outcome measure. The ones that found that reading connected text were using reading connected text as the outcome measure. But she didn't look at in between those institutions, so this work was very much inspired by hers and asking the question. So I'll get to the question in a moment. Here's just sort of the shape of the experiment. Before a story, the tutor previews 5 of the hardest words. We just pick the longest. And then the kid reads the stories. The child reads the word and then the tutor reads the word to make sure they heard what it was. And by new, I mean they haven't seen that word or the same group before the tutor. And what we're going to vary here is the independent variable. I hope the independent variable kind of rings a bell from a standard course, is how much context I see the word in. And it's all randomized properly and so forth. So there are 5 different things we can compare. One of them is a no exposure control where there's no preview. So when I said they preview the 5 hardest words, I kind of lied about the first one. One of them is just practicing the word in isolation. So let's say the word's difficult, okay? So in isolation, the kid would just see this. One of them is practicing a bigram, so that just means a word pair. And the rationale for this is that there's something apparently that's going on when kids practice words in running text that they get from that practice that they don't get from practicing words in isolation. What might that be? One thing it might be is practice in looking at one word and kind of peeking at the next at the same time. Keith Rayner, who's the world expert on children's eye movements and reading, and has studied them. He actually has a paper called 20 Years of Research on Eye Movements and Reading. Has a nice model of what you look at when you're reading and what's going on in the head at the same time. So maybe it's that sort of learning to look at one word and peek at the next. Maybe it's some sort of syntactic processing. So that maybe it's important to see a word in a phrase because you're learning to identify words at the same time as another part of your brain, or at least mind, is kind of parsing. And maybe you have to see words in a sentence because then there's some comprehension process going on. I didn't know which of these. I made these things based on these hypotheses about what might be going on. The outcome we want to know is the first time they encounter the word in the story proper, how do they read it? So do they click on the word for help? Do they hesitate before the word? How long does it take them to say the word? All right. So this number is not as large because here was just the experiment, not all the words that they saw. It's still a nice big number if you're a psychologist, I guess. And the outcome measures were what percentage of words were accepted by recognized as correct, how many words did kids click on for help. Let me unpack this into English. How many words, if they were accepted without help, what percentage did they hesitate on? That's what this says. And if they hesitated, how long did they hesitate? Just if you look only at the hesitations, how long were the hesitations? And how long were they, did they read? And we normalize the hesitations and production time by the number of letters because there's a strongly linear relationship between them. So how long did they hesitate per letter? Let's see, how many of you have heard of regression? By the way, regression applies here in 2 senses. The reading sense is looking back, but here I mean the statistical sense. You probably haven't heard of, some of the professors have probably heard of linear mixed text regressions. And I'm just going to go through these and not explain why because I want to get to the results. All right, so here's the percent that the kids click for help. We've got this pretty nice looking curve showing that previewing in more context reduced the percentage of words that the kids clicked on for help when they saw that word in the story. Here's how many they hesitated on. So again, seeing it in more context reduced the likelihood that they would hesitate. But a funny thing showed up in the data, which is that if they hesitated, for those hesitations, it didn't matter how they had seen it, what the preview was. So that was a kind of a cool surprise for us. So in other words, these differences here are not statistically reliably different. So here's a summary of those results. Previewing the word that's going to be this hard with the story in a phrase or sentence made it less likely the kid was going to need help with the word and less likely the kid would hesitate, but it didn't affect how long the hesitations were, if they did hesitate. And when we presented this at the Scientific Studies of Reading Conference, somebody whose name I used to have on the slide I took out because I was afraid it would confuse people. I forgot it. Turo or something like that, said maybe what's going on is that when they see a word, if they can't retrieve it, then they just have to decode it. And if they couldn't retrieve it, it didn't matter what sort of preview they got. It's a hypothesis. And I was interested in the same about the hesitations. So we looked at all the words, not just the first encounters and not just the hard words, and we looked to see, if you look just at the hesitations, is there any pattern we can see in these hundreds of thousands or millions of words? Is there anything that predicts how long they hesitate? And our postdoc looked at this, could not find a single predictor that had a relationship with the duration of the hesitations. Probability of hesitation, yes. Duration, no. So that was kind of a fun surprise for people like Dana. All right, switch gears. Oral reading fluency is not just reading fast and accurately, it's reading expressively. If you remember, my cat is fat. As opposed to my cat is fat, which you could. All right. Paula Schwanenflugel is the world expert, so far as I can tell, on children's oral reading prosody. Now, prosody, if you're not, how many of you have seen the word prosody before? Okay, half-ish. When I was young, ish was not a word by itself, but I learned it from my teenage daughters. It's incredibly useful. You know, because somebody, you can say something and pause for a while and say ish, and you know, they understand what you mean. We had to say things like sort of. It took much longer. Anyway, what Paul had found was that the more expressive a child reads, the better they read, the greater the extent to which their oral reading prosody is adult-like. And there's a mathematical or statistical sense of what I just said. So it's true in a very literal sense that the more expressive your reading is, the more it correlates with the prosodic contours of adults. So, sorry, prosody is pitch, amplitude, and duration. So,
they have to put food on the plane so that we can
eat. So that's it's got at the end. So that's an adult narration. Here's a fluent kid.
They had to put food on the plane so that we can eat.
Here's a dysfluent kid.
They have to put food on the planet.
At this point, the tutor spelled out the word that.
That we can eat.
Watching a dysfluent kid or listening to a dysfluent kid read, unless it's your kid or you have a professional interest in reading, is as exciting as watching paint dry. You have to be really patient because it's less than a word per second. Shall I continue? No? All right, didn't think so. So we did a bunch of studies. Let's get to the fun graphics. There was a wild and crazy idea that I had that was inspired by an artist named Roland Levin at Carnegie Mellon, who used the human voice to control graphical displays. And he had museum installations where, depending on like what vowel sound you made or how loud or how high, it controlled something about graphical appearance of shapes, like the color or what shape it was or size and stuff like that. And he had museum installations. Kids loved it. And I thought, wow, how motivating it might be if children's voices could actually change the words on the screen, which you may have noticed books don't do, right? They just stay there. And could we harness that motivational power to motivate kids? Because motivation is, I didn't list it as a skill, but it underlies everything. The kids with the most difficulty reading are the ones least inclined to do the practice that they need the most. So that inspired me, and I thought, okay, surely the world expert on world prosody is going to shoot down this idea because it's just too crazy. But she liked it. And so did the reviewers at National Science Foundation. Sorry, not National, let me think. No, that was Department of Education, Institute of Education Sciences. So we got a grant and that was part of it. So I'll show you some of what we did. This is work still in progress. And I'm going to skip some things. Let's see. I usually take longer to go through this slide, but I want to leave more time for other things. Suffice it to say that there are various different properties of prosody. There's the word, there's the length of the word, that is number of letters, there's how high it is, there's how there's just time going forward, there's how long it lasts, there's the hesitation or latency, there's how loud they say it, and there's also how confident the speech recognizer is that they actually said it. Now, those prosodic properties could be expressed graphically in lots of different things. There's lots of things that you can have with graphics. You can have a text label, you can have different shapes, you can just label something. There's how high you put something on the screen. There's also time, because you can have a dynamic display. There's how wide something is, there's space, there's height, there's font size, and then there's all sorts of things you can do with color. Color has saturation intensity. I'm going to whiz through this because I really want to show you the vocabulary stuff. So the short version of this is that depending on which prosodic properties you map to which graphical properties, you get different sorts of displays.
They had to put food on the plane so that we can eat.
So here we represented each word as a rectangle, and it went away. So I forget what the colors. But the point is that that's one way to do it. If we change things, instead of representing words as rectangles, represent them as text words.
They had to put food on the plane so that we can eat.
Then you get something that looks different. So this is the sandbox that we were playing around in, because there's a whole space of different ways that we could map, and that's what we're exploring. So cut to the chase for the experiment that we did. After a bunch of user testing, we want to know two things. One of them is, if kids had a free choice, would they prefer that sort of graphical display, which I was really hoping they would, or would they prefer not to be distracted by it? So we did an experiment. The kid with the tutor still picked the story to read, and then sometimes it would display, okay, so here's what it looks like without displaying prosody.
Jack saw the miraculous hen. Jack saw the miraculous hen from a creek, from a crack in the oven door.
Here's some background class noise. And you can't even see it there. There was actually some very subtle shadowing to reflect the position. It was just 1 pixel wide, so you wouldn't see it back there. But that was sort of the point. There's almost nothing to see. Here's what it looks like, and believe me, it's the opposite extreme.
And around the fire sprang the most grotesque little man, hopping on one leg and crying.
Grotesque?
So that's just giving correction on a word miscue that the reading tutor actually managed to hear. So there you can see there's color. There are those lines which represent the adult. Did you want to see that again? No, good. We'll get on. Anyhow, do they like it? Well, how can we tell? We can measure how long do they stay in the stories when it's on, how long do they stay in the stories when they're off, and how often do they finish the stories supposed to be able to out, because kids only finish like about half of the stories they start in the tutor. And the bad news was that they didn't have a significant preference for it. The good news was at least they didn't hate it. So this was just a tie. And the thing that we're still analyzing the data to find out that we really want to know, if you show this positive, does the tail wag the dog? Does it actually cause them to read more expressively? Okay, now we're on to the vocabulary parts. Here is a one-slide summary of a PhD thesis, or actually a chapter from the PhD thesis. We wanted to know if you just introduce very quickly a vocabulary word the first time the kid sees in the story doesn't make a difference, that you can tell. So the idea was, well, explain some of them, and don't explain the others, but then test all of them the next day the kid uses the tutor. And just randomly choose what to do. Now you have a randomized controlled trial. So Greg, being a language technologies PhD student, used some language technology, something called WordNet, and he generated these factoids about words automatically, which is why they don't look like Shakespeare wrote them. Okay, Shakespeare would not have said, reply is a kind of tell. Well, for one thing, reply is a verb. But this is the sort of thing the kid would see just before a sentence that first sentence that included the word reply. And then they'd read some more. The next day, use the tutor, they would get a test that looked like this. And the tutor would read this aloud. So it would say, what word is most likely replied? Soft pedal, observe, play down, and answer. It would highlight each one in turn, and the kid would click on, hopefully, the last one in this particular case. Okay? And they would get this whether or not they'd gotten this little factoid. Results of that experiment was, yeah, it actually did make a difference for rarer words like astronaut. But for a word like apple that the kid already knew, of course it's not going to make a difference. All right. Fast forward, that was back in 2000, we did that experiment. I'm very proud of the fact, this is a key thesis, right, language technologies. It was a distinguished finalist for the International Reading Association Outstanding Dissertation Award. You go, Greg. Okay. Here is the latest experiment that we did. And I'll show you some of these videos, but it would take too long to go through all of them. I just want to give you a flavor. But at least I want to explain what the experiment design was. The idea was to compare 8 different dosages of vocabulary instruction, ranging from none, not saying the word at all, that's a no exposure control, all the way up to all of these steps. Seeing the word in the story, getting quick explanation, but sort of like in Greg's work, then intensive instruction, and then on successive days, other activities designed to elicit active processing. Our vocabulary expert really got that through my head. You got to make the kid think. That is what's going to help them build up the rich lexical representation of the word that they need so that they can retrieve its meaning and understand it deeply later. And then after all those things, they would get a post-test again in a separate word, and a delayed post-test a week later. So I'll just show you some of these, but at least I want you to get the idea. And how far a word got through the sequence was random. Okay, so they would get nothing, or just seeing the word in the story, or seeing the word in the story and the explanation, or that and. Okay, so it's how we randomized how far through they got this through the sequence. The pre-test looked like this.
Before you read the story, I'm going to ask you some questions. I'll show and read a word to you, then ask if you know what it means. Please answer carefully.
Tradition.
Do you know what
tradition
means?
And if the kid said no, turns out they really don't know what it means. If they said yes, we would give them a 4-item multiple choice. If they failed that, then we would include the word in the study. But if they knew it, there's no point in teaching it, so we would discard it. Then I'm going to skip just seeing the word in the story because you can imagine that. Here's what the quick explanation looked like. So I'll tell you ahead of time what you're going to see, because otherwise it will go by too quickly. The tutor is going to read the story. It's going to just say, highlight the word, and we're using the word tradition, and speak a quick definition of what it is, and then it'll be the kid's turn to read the sentence. Looks like this.
Christmas Day. Christmas is here.
If you celebrate Christmas, what are your traditions on this day?
So that's actually a sentence
If
from the
you follow
story.
a tradition, you do something the way it has always been done.
That's a spoken explanation.
If you celebrate Christmas, what are your traditions on this day?
Kid's turn to read the sentence. And goes
How
on,
do your relatives and friends celebrate the holiday?
and goes on to read the rest of the story. Okay. I'm trying to remember one of the, let me skip to these. So that the exercises are successively harder. And my intent here was to show sort of a day in the life of all the trials for a single word. And the activity, so I am including the prompt for the activity, but the kid would get several words, so there's not the overhead of the whole prompt. Let's see.
How about some tougher ones? Let's see what you can do with these questions. They might be tough or tricky questions, so think carefully. First, I'll ask the question. You answer yes or no. Then I will ask you why you chose your answer. Can
Tradition.
Start.
Yes. Tell me out loud why you answered yes.
Because.
Anything else to add? Can
Tradition.
do something
Bravely.
yes. Tell me out loud why you answered yes.
Because you are strong enough, you could be proud, and that's it.
Anything else to add?
Because you are strong enough, you could be proud. So the kid has some notion of the meaning of tradition, clearly not a complete definition. And also clearly it's a kid. So the post-test looks like this. And the reason for asking those questions, that's not a test, it's to make them think. That's eliciting the active processing. In order to think about, can a tradition starve, it makes you think what are the properties, semantic properties of tradition.
You've been working with a lot of new vocabulary words. Let's see how much you've learned so far. Please answer these questions and make sure you do your best. Which has more to do with
Tradition. What you do every year for a holiday. Having fun at a holiday party.
which has more to do with
Tradition. Having fun at a holiday party. Someone wearing a wedding dress.
And there's no feedback there because it's a test. And then a week later, we get the delayed post-test, and this is based on the definition.
You've been doing a lot of vocabulary work. Now I want to test you on some of the words. Here's your chance to show what you've been learning. These test questions might be tough, so make sure you look at all the choices before clicking on your answer. Please do your very best on this vocabulary test to show me everything you've been learning. Please answer these questions by clicking on the word that fits best. Click go when you're ready to start the test.
A tradition is the way something is blank, done, finally. Sometimes, always, not a tradition.
So that is choose the wrong answer. All right. I should mention that the videos there were reconstructed from the log data because we don't log screen capture video of everything. But the recordings, as you heard, were authentic. Next. Oh, results. You might want to see the results of the experiment. So here's the percentage of top words learned. And what it shows is that compared to the no exposure control, or only seeing the word story, this additional stuff really did help, at least up to this point. Maybe this last step wasn't necessary, but these are confidence intervals, so we don't know those numbers precisely. And what these numbers here are how long it took. So what it boils down to is something like 5 minutes or whatever this time adds up to over the course of several days was sufficient to teach a high percentage, I think something like 60% of the words taught for kids to learn that percentage. For studies of vocabulary instruction, that's quite high, especially and the studies that got that far had much more time-consuming classroom instruction. So we're pretty pleased with that result. Okay, stuff that we're doing currently, we're adding eye tracking and EEG, and I'm going to skip to the end because it's been a long time. If somebody wants to ask about gaze or EEG, I'll have to go back. So, in summary, what have we learned about reading? Wide reading beats repeated reading for most kids. space beats mass. It does make a difference that the kid gets to pick the story, although we're not sure if it's because they're better at picking stories or just because of the fact that they get to pick. It actually looks like they're better at picking the stories. Seeing the word beats seeing a word with the same root, and we didn't find transfer for words with the same line. Rhyming hints win out in the long term over just supplying the word. By the way, that also depends on the level of the kid. Once the kid gets more proficient, just supplying the word actually seems to look better. Longer context seems to be better than less. The kids accept the graphical display. We don't yet know whether it actually improves expressiveness and vocabulary. This rolling admissions design, this is not a conventional design where you administer a pre-test with a whole battery of words, and then to get instruction, then you administer a post-test. There's a bunch of practical problems with those designs. First of all, kids enter and leave schools all the time. So if you administer a pre-test, there'll be kids who are absent, there'll be kids who show up to enroll the next day, miss them both. And then at post-test time, there are the kids who move away the day before the post-test, and both times you made the teacher mad at you because you're taking away their students when they want to teach. Whereas if you hide it in the tutor, it's not a student for the classroom time.